Students, so today we are going to talk about entity framework, database development, what are different development approaches, what is the code first approach that we will talk about, and then how we can connect with the SQL server. And at the end I will show you how we can do it practically with a specific scenario that we will be discussed later. So before the .NET 3.5 we have EDU .NET, that is a database connectivity for the Microsoft platform, connecting with their different type of database servers, maybe SQL Server or even the Access. You can connect using the EDU.NET. So we have open database connection, create database set for the reading and writing from or /2 db, convert data to the .NET objects. So all these things you need to write the connection string, you need to provide the user information, security, you need to write the SQL queries within your program so that you can communicate with certain tables within the database, and then you can bring those information back, how we can update this information in the database table and so on. So these, what you get, this programming style was prone to errors and cumbersome methods. So we have a lot of what you can say that redundant code that we need to write again and again. And with the new advancement in the technologies and the new advancement in the techniques, so the Microsoft have introduced an entity framework. Entity framework is more like that you are writing the programs, you are writing the classes, and you are writing the code, and then from that code seamlessly you can create the database, you can update the information, you can retrieve the information from the database. You don't need to write any kind of SQL query, rather than you are just working with different type of the objects which are present within your program. So with the entity framework, of course, at the back of the entity framework is edu.net. It's an open source ORM framework for the edu.net and open database connectivity. So again, at the back end, edu.net is working, but we don't need to communicate directly with them, and then we don't need to set those things. So interaction between .NET application and the relational database management systems, object relation mapper, that's called ORM. It's an open source, simplifies mapping between the objects and the database tables. I will show you with example that what does it mean. It will convert a class into a table, and the members of the class or the properties of those class into the fields of the or the columns of that particular specific table. You can add object in that particular specific table, and that automatically become a row in that table. So we will discuss. So ORM is enables developers to work with data using objects for the domain specific classes without focusing on the underlying database tables or the column names and how we are going to save them, how we are store them. That is automatically handled in the background by the entity framework. Entity framework ORM takes care of the creating database connections, executing the commands, taking query results, and automatically materializing those results as an application objects. If we are reading some records from a table, so that table, yes, we have the table, but actually each row in that table is becoming an object inside our program. So it will become a list of objects that we need to work with, and then we can obtain. And the other thing is that particular specific, it tracks changes to these objects. If there is some change in that object, it will automatically generate the update query and update the informations or the changes in the database. Increase developers productivity by reducing the redundant task, persisting the used data. We can use the data and we can save them permanently in our database, generate the necessary database commands for reading and writing the database and execute them. That everything is done and handled by the entity framework, and we don't need to worry about that ourselves. Express queries against objects using the link in the entity. So we have talked about in the previous lecture what is a link. So here we will see that how we can query our database objects, which actually comes in form of the list. So in our programs, and then we can use them and change them. We can do whatever we want to do in our program, applying the different business logic and changing the informations, deleting the information. So everything in the background on the database end, everything is handled by the entity framework. So if we look at, we have the user interface. That is how the user is interacting with the application. The business application intelligence and business layer, where we apply all those different types of business logic. We create the classes, we create the entities more like a class, but when we talk about a database, it's become an entity. Actually it is representing a class. So, and then we have a data layer. In the data layer, entity framework is communicating with the database based on all the logic that we have applied in that particular specific level. So object relational model, okay, that is help us to translate the classes and objects into the database tables, or the rows and columns. So that is helpful for, and that is one of the feature of the entity framework. Features that can be used in the entity framework code, that's a cross-platform modeling. It will help of entity data model. We have an entity data model based on the simple plain objects with the getter and setters, and querying. We can query using the link queries. We can apply certain queries. We can keep track of changing in the objects, and then based on the state of the object that it is added or we need to insert. If it is changed, then we need to update. If it is deleted or removed, then we can delete that particular specific record from the table. And if it is unchanged, then definitely we don't need to do anything. So saving, so we can insert, update and delete. Even we create the tables and create a database. So everything is handled by this particular entity framework. Concurrency, again, automatic transaction management. So it will manage the transactions. It will keep the integrity of the data. Caching, it will include it will cache the changes and informations within the RAM, and then automatically it will be automatically handle that caching, that when we are moving data from our program to the database or database to the program, it will automatically handle that particular specific caching thing. Configure model using the data annotations. We have a lot of data annotations. We are not going to cover in these annotations in this lecture, but in the next lecture we are going to cover that one. Then we have migrations, set of the migration commands that you get package manager console. So we have set of different migration commands. We are migrating the data from one server to the other. So if there are changes in the data model, that how we can implement those things and all that behaviors. So currently the entity framework has two different models. One is a core model. It is more like that we are talking about the cross platform. When we are when you want to develop something on the Mac, then Mac or the Linux, then you need to use the core entity framework core, or if you are on the Windows platform, then you are using the entity framework 6. Okay, so this is our how it works. So we have a map of the classes to the database schema, translate link to the entities, translate the link queries into the SQL queries, keep track of changes, and save those changes to the database. So these are some application programming interfaces that we are using under the hood of the, or under the framework of the entity framework, and then we can help and develop our database applications. So there are three different approaches. One is the database first approach, second is the code first approach, and the third one is the model first approach. So database mode first means that we first go into our database management system, whether it is a SQL Server or the MySQL or the Oracle. We have a lot of different type of relational database management systems. You go into database and you create the tables and everything, and then you connect with your project, and then entity framework translate those objects or tables into our entity and classes and to context. We will talk about what is in context, but it will convert all those tables, things, and into our classes. So that is the one thing that we need to one way to develop the database applications within the C#. The second one is we have defined the domain classes. That is going to be discussed today's lecture, and this one we are going to discuss later on in the next lecture. So domain classes, we define the model of the data model within as a class within our application, and then entity framework is automatically converting that classes into the tables and rows of database, and it will create that particular specific database as well as the tables within that application database, RDBMS and so on. Okay, so this is the second approach. And the third approach is that we have the visual designer within the Visual Studio, and then we can design the database model using the graphic tools, and that will automatically generate the classes, and it will automatically generate the database and the tables inside that. So that is the third way to do the database programming within the C#. So let's talk about the code first approach. So in the code first approach, we have a conceptual model, and that is a class. So we have a class, student ID, first name, last name. We have all those set properties sets over there, and if you look at that, it's a simple class name is a student, and then we have a student ID, we have a first name, we have a last name, and we have defined their data types, and then we have a set and get methods. On the other side, if you look at the storage model, because that we are talking about the relational database. So in the database, it will be a table, and that table name will be student ID, that will be a primary key, and integer. It cannot be a null. Primary key must have the value in it. And then we have a first name and last name. These are the second and third columns of that particular student table, and then they have the type of the string, the maximum length that can be 50, and then they can have the null values as well. So this is our storage model within the database that will create a student, and then it will create a student table with the 3 columns, and we have a conceptual model. So entity framework comes in between that. Okay, so converting that particular specific class into a table. So the name of this class will become the name of the table, and then the fields of that particular specific class will become the columns of that particular specific table. So this is our code first approach, and I will show you that how we can do that. The second approach is database first, so in which we could generate the database model first, and then based on that particular specific database model, entity framework automatically generate our class in our program, and then we can use that particular specific class as we are using in the other approach. Here, one of the very important class that is a database context, which represents a session with the database. It is more like it will we have read a few records from our database, and in our program we have those records as the objects or the classes of an object, like student object and or list of the student objects, and then we are doing some changes in it. We are deleting some, removing some record, we are updating some records, we are changing some records, even we are creating a new database, so a new table inside our program. So all these things are being recorded as a session within the database context, and once we call the save data method, it will automatically update those information inside our database. So we can perform the create, read, update and delete operations. The base class for that particular specific database context is the system.data.entity.db context, and before we can use that particular specific class, we need to import, we need to add our entity framework as a package within our program, within our project. So track multiple changes under the single database transaction. We can query or save data to the database. We can configure the domain classes. We can database mappings, change tracking, caching, transactions. Everything is handled by the context class. And once we have added the entity framework within our project, after that it is very simple to write a context class. So we have a student class that we have defined, a simple class in which we have a student ID, first name and last name, 3 properties. Here we are using the system.data.entity and then in that particular entity library we have a DB context class. So we create a new class school context. That again, this is the name of the class. You can choose any my database context or whatever you want to select. So but this will be the child class of the DB context, and in this DB context we are just saying that we are database set, DB set. DB set represents actually one table, so we are saying that it should be a type of the table, and the students name, the name of the variable. We have a get and set method, and that's it. So we have created a context, we have created a one table or one class which is going to represent a table within our database. Now we can use that particular specific context and the child. So first of all, again we are writing a hello database world as a in our main program, and then we say creating a student object, and then we are assigning the value. Student ID is 1, first name is Abbas, last name is Malik, and then we are saying that context is equal to new context. So we're creating that particular specific context. When you create that particular specific context, remember that that particular specific context will help us to create a database within our local DB. Because if you have not installed anything, like you have only installed your Visual Studio by default installed a local DB database engine within your Visual Studio. So what it will do, it will open that in that particular local DB engine. It will create a database with the name of your project name dot the class name, the school context. So the context name is actually represent the school context, and the project name is for example for this demonstration I have created a database application. So database application dot school context, that will be name of that particular specific database, and normally it is saved on the c:/user/username/users in the Windows, and then you have the username, whatever. If you are personally using, if you are using a computer within the lab, you have a student ID as a username, and under that particular specific folder you can see that particular specific what you can say that the database will be located over there. Sometime it go into the document folder within your username, so it is also possible that it go there. So if you don't find at that location, you can see into the documentation. So what's happening here, what we are saying that in the context, that is the variable that we have defined of the school context, and then we say students, because that is the one we have defined here, students. In the students, I want to add student, the new object that we have created, it is added. So it means it will actually create an insert SQL statement, and that is saved within the context. And then when you say that context.save changes, it will execute that particular SQL statement on the database. And if the database is not created, it will also create the database, it will create the table, and then it will insert that particular specific record inside the student table within our database. So once we have save changes, it will go and update the records in the databases. So this particular simple program, it will create number one, database at a specific location. Then it will create a student table based on the simple class that we have defined here, and then it will, once we have added that particular new student object inside our context or in the student's context, then it will also insert that particular record inside our database. So what I did inside our server explorer, what I did, I tried to contact, so we have a database application dot school context dot ndf, that is the database that has been generated automatically by this code, and I connect that particular specific database inside our server to look at, I have created that student table. So look at that, I haven't created that database, it's automatically done by the entity framework, and the database is there. And once we right click on that particular student table name, and then you say that show me the data, it will show you that you have one record, that is one Abbas and Malik. So that everything is done by the code, and we have not touched the database at all. So that is called the code first approach. Now we can also read the data. we have inserted one record, so we can translate link to the entities queries to the SQL queries for the relational database using the EDM, that is entity data model. Okay, so the converts results to the entity objects, and then we can use, for example, if we want to read the same record that I have just added into my program, I say that into my database, so I say variable context equal to new school context, so I creating a context that will help us to connect with the database which is already existing. And then query is equal to from s, I'm writing in the query syntax, so from s in the context dot students, so we have students list which is read from our database, and then it is going to be we have s, and then we say select s. It means that we are trying to get all the records from our students table. So what is happening here, so it is a query, and as you know that it is a deferred execution. It is not going to be executed when we are defining it. Once we are using it, it is going to be executed. So, and it will return me back here as a collection. So we can say that for each variable s, for each student object s in the query, we want to write student info, student.id, and the first name only. So once we do that, it will give me it will show me the result that 1 and Abbas. Okay, on the other hand, if we try to what you can say that modify the data, so how we can do that? So again, we are opening the context, we are creating a connection between the program and the database. We are saying that we are trying to get a student object context.students.find. so when you say, now we have not set anything, we said find one, so it will automatically go into the students table, read all the record, and then find the record which has the student ID 1. Okay, so it will return me student object. So we say student.first name is equal to, instead of like Abbas, I say MG Abbas rather than Muhammad Ghulam Abbas Malik. So I have a long name, so I've abbreviated the first two first names as M and G, MG Abbas Malik. So context.save changes, once we saved in that particular specific update has been done inside the and then we again just like we have read last time, we again read the information. We have a query, and then query will be executed when we are going to use it. So it will return me the collection or the collection of the students. For each student we are trying to print the name, so it will print that particular specific student info 1 MG Abbas. So it is actual, what you can say that the output of the program, that is I'm showing as a screenshot here. So you can see that the changes which I made, it is clearly shown here. Okay, again, if we want to delete it, the context is the main thing, that we need to create a connection between the program and the object. Once we created the object connection, we can say that context.students we want to remove. So when we want to remove, so again, so in the context.student.find one, so which specific record we want to remove. If we want, so we are saying that find that particular specific student who has the student ID 1 and remove it from that particular specific student's context, and then we save changes. So when we do that, it will remove that particular specific record. I can see that inside my database, so that record has been removed. So in this way we can perform the the logic and the things that we can do. Okay, entity framework conceptual model that we talk about, the model of the objects in an application, not a model of the database, objects aligned to database, or it can be totally different. If we apply different annotations, then it's possible that we can have a different table name and the columns names inside the table, and inside the object they have different names. So that is also a possibility. Define your classes and use a feature of the entity framework called code first to design the conceptual model. So we define the conceptual model based on our entities and classes, and that will be translated automatically using the ORM, object relational model, object relational model. So that will transform those particular specific conceptual model into the database structural schema, and that will be written down on the database. Data providers, again, we have different type of data providers which can help us to communicate. Again, if we talk about the Microsoft suite, we have ADO.NET. If we talk about the MySQL, we may have a different provider which will help the entity framework to communicate or the work with that particular MySQL. We also have PostgreSQL. So again, each and every different databases have their different data providers, and based on that, using those particular data providers framework, entity framework can communicate with those type of data relational database management systems. Entity client provides ability for developers to work against entities in the form of rows and columns, and core functionality entity data model layer. So it is more like that we are not working with the tables, we are not working with the rows, we are working with the entities or the classes. So that is another feature of the entity framework that we are using. Again, we have a storage layer, entity layer, mapping layer. Storage layer is more like a database schema, how it is being stored in the database, and that is saved as an XML, and then it can be executed inside performed or replicated inside the database. Entity layer is more like define the relationships and the entities, relationship between the classes and the tables, and then we also have the mappers, which is mapping this entity layer to the storage layer and help us to segregate the programming logic and the storage logic. Metadata services, again, centralized API to access the metadata stored entity mapping and storage. So this is more like that how we can access the metadata of the database. So this is the model that we are going to what you can say that we are going to implement in our practical session. So here we can say that we have a student which has the ID, and I would say that student ID, not the ID, student ID, last name, first name, enrollment data. And if we talk about the courses, so many students can have many courses, and many courses can have many students. So actually, if you look at that, if we try to find out a direct relationship between the student and the course, it's a many to many relationship. So that relationship is not going to work within our database implementation. We need to convert that many to many relation into one to many and many to one. So if we talk about one to many relationship, it means one course can have many enrollments. Similarly, we can have one student can have many enrollments. So many enrollments can be associated with the one student. So many to one relationship or one to many relationship. So M to M relationship need to be break down into one to many. I mean, if I just try to we have this one, we have one here and many here. The relationship between these two is many to many. Okay, so we have this many to many. So we are breaking that particular specific relationship into the one to many and many to one. So that will help us to save that particular specific. So because we can't define that particular specific many to many relationship, because there will be a lot of data redundancy and so on, so that we want to remove. So it's more like normalizing the database. So that is different type of relationship which exist in between the tables, between the entities. So one to many relationship, many to one relationship, and many to many relationship. So this is the model that we are going to implement in our practical session. So again, when we talk about the entity, class included as a DB set in our context. So we have a three entities: student, course, and enrollment. This is our student class, in which we say class student ID. We are putting ID as a capital ID, and then we have this one. So we have all these properties, and we have this set and get methods. We have courses, course, set, and then we have set and get methods for all these courses. We have course ID, we have title, we have credits, we have the I collection enrollment set. Similarly, we can have the enrollment ID, we have the course ID, we have the student ID, we have the grade, and then we have the course and the student. So we have these kind of information here. Okay. Scalar property, primitive types of called the scalar properties, and we also have the navigation properties. Our relationship is to another property. They are more called reference navigation and the collection navigation. What does that mean? If we talk about this, if you look at these courses and enrollments, these particular specific properties are the scalar properties because they are of the integer type, string type, and these are the primitive values, primitive data types. On the other hand, this one is a collection navigation property. Why? Because it is a type of the enrollment. So it means that this particular specific enrollment object, a collection of enrollments of objects, that is another entity. So it is a navigation property which is navigate from one entity to the other, but it is a collection, so that's why we call it a navigation collection navigation property. On the other hand, we also have a reference navigation property. Here we have created a reference of the course entity within the enrollment and the student entity within the enrollment. So these two are the references of the objects of the courses and students within the enrollment. So that's why we call them reference navigation, because these are representing, we navigate from, we are going from enrollment into the course entity. So again, we are navigating between two different entities. So that is the entities. So how we can entity can have different states, maintain each that is maintained by the what you mentioned entity framework, and the context is managing that particular specific state. It's added, modified, deleted, unchanged, or detached. If we look at that, so we have a database context, which we have entity, keep track of each object. We have multiple what you can say, the objects of the same entity. So we have entity added, entity modified, entity deleted, or entity unchanged. If it is added, it will insert in a new record in the database. If it is changed, it will update the existing record in the database. If it is deleted, it will delete the database. If it is unchanged, it means that it is not going to perform any kind of database execution. And sometimes remember that when we say link and then we say convert that particular specific thing into a separate list, so that is detached from the database context. So when it's detached, it is not, if we change anything here, delete that particular specific thing or modify that particular specific thing or add a new entity over there, it is not going to be recorded in the database context, and because that is detached from the database concept. And then we have a snapshot of the data at a specific time, and then we can use for any purposes, but it has nothing to do with the database. So that's another state that is present in the entity framework. So how we can do the implementation? First step is that we need to writing those classes. Second, we need to import the entity framework. Third, we need to create the database context, and then we can write the code to manipulate the data. We can add a table, we can add the data in the table, we can delete the data, read the data from the table, we can modify the data in the table, or we can delete the data in the table. And we will follow these particular specific concepts when I will record a second video about the practical implementation. And that is these are a few links which are present in the lecture, and from where I have learned all those information. Thank you very much. Have a good day. Bye.